Hi, this is Jeff Huang, part of the second group of the Cirkits VR project for CS370 Spring of 2024. This video is a companion video to one made by my group mate Christian. This goes into the logical reasoning of our code, goes a little bit more in depth about what we did, why we did, and how we did it. And it's mostly a tutorial regarding what we did for our project, and hopefully it helps other people in the future when they look at what we did. So let's get into it. The goals for our Cirkits VR project given us to by our clients was ultimately to create a circuit simulator. Now, to make a simulator or a free build kind of application, you kind of need three components. You need a ability to spawn the parts for the simulator. You need to have the user be able to manipulate the parts for the simulator at will, and you need to be able to delete them. We have done that in general, mostly. Unfortunately, we didn't have enough time to finish recoding all of the actors to work on the simulator grid. But there's also a few things we had to change because we were making a simulator. And one of those changes was to change the controllers from a physical grab to a point and grab system, which you should have seen in the other video. Users should be able to point at an object that is done by a cursor through a sphere trace, press a button, and the object will snap to their hand. Let's get into the general code for all of these. So, as you can see, for our cursor detection, or basically how the cursor rays follow our controller, is done through event tick. There are three general lines of functions running through all of these pieces of code. This is a sphere trace specifically for the grab component. This detects actors that are hit by the sphere trace, similar to a line trace, checks if they are grabbable through this grab component, and then they will be grabbed through the grab function. This is the sphere trace done for the right controller. This checks by looking for where the controller is pointing, generally adds a little bit of distance in order for it to detect something that it hit, looks for a hit, checks for a specific interface that we used for our project, disposable, and through a general branching set of true and false conditions will either highlight the object in order for it to know that it's interactable, deselect it if you move the cursor off, etc. And sets it to a selected right actor. We generally store the actor data on the VR pawn itself. If you can see that there is a selected right actor for the right, a selected left actor for the left. These are just basically variables to store the actor to know that this controller is looking at this specific actor right now, and if I interact, I'm going to interact specifically with that actor. Now, the last one is a sphere trace for the left controller. As you can see, we get the vector location and direction from the left controller. We then attach a sphere trace to that direction. We check if it hits a disposable interface related actor, and depending on whether you've actually hit a disposable interface actor, these event functions will be triggered. Here is delete, highlight, low light, I couldn't find the right word for it. Low light is basically deselect so that it stops highlighting the actor that you're pointing at. Let's get into the grab function for our project. Now, the grab was a little bit tricky because in order for a part of our project was being able to not only grab components so that they snap into your hand, but if they went and looked at a specific actor, specifically this component lock, it would snap to this location and a specific direction when you let go of the button. You can see that component lock there, it is here, and we have repurposed that component, that actor, to basically work for the simulator board. Let's see. So, yeah, this is a check to place the component lock from a specific distance using a sphere trace again, invisible sphere trace, to check whether we've hit a component lock. If it is, then we set it to a specific rotation. If not, then we do it a little bit differently. I believe this is just a regular grab. This just grabs the actor from anywhere. And then this is to make sure that we've placed the component properly. Now, there's two behaviors regarding this grab function. If you let go of the actor, if you let go of the grab button and you're not pointing at component lock, the actor that you're holding is supposed to fall a few meters in front of you on the ground. Yeah, but if you are pointing at a component lock when you let go of the button, the actor is supposed to teleport and rotate properly to the proper component lock location. And this is a long string because we didn't really optimize it, but this is a long mess of functions basically to account for different behavior. So this is we have several conditions regarding what type of actor it is. If it's an actor, we need to set up a specific rotation and location for all of these actors. There's one for the switch, there's one for the wire blueprints, and then this one at the bottom is supposed to be if you do not actually point at a component lock at all. Then it centers all the behavior because it's supposed to check, let go properly, and then the function finishes by releasing the component into a specific actor at a specific location, and then it resets the variables regarding holding the component in your hand. Another part of spawning components at will is for our team, we made a menu. So this is a menu that we made that you can call by pressing a specific button. I actually don't remember which button it is on the controller. Let's see, IMC default menu, toggle right. It looks like it's just the menu button on the Vive. Okay. But this menu, you use this button to reset everything if you've made a mess of your level. These all spawn the different components relating to all of the actors that have been created so far. And then here is the event functions relating to spawning the menu and the actors related to it. So yeah, you get the actor forward, camera location, and then you spawn these actors a little bit, because it's times 100, a little bit distance in front of where you are looking. And these are just all the different actors that you can possibly spawn using the same location. with different settings. So if you've been looking through the previous function, you'll notice that we've been using sphere trace so far instead of line trace. And the reason for that is because sphere trace has a specific variable called radius. You can change this radius to basically enlarge in or like make bigger or smaller the detection radius that the sphere trace can hit. A line trace does not have this component. So if you make the radius a little bit bigger, it makes it easier for your user to actually hit, quote unquote, the actors that you're trying to interact with. I believe it's generally 3 for all of them. Oh, I guess not. It's 2 for that one. 3, 2. But yeah, 2 to 3 is a generally comfortable radius for your users to not have to have precision-like aiming to grab and press buttons and interact with actors. Now, if you've been looking around so far, I believe we talked about the disposable interface for our actors. Disposable is an important interface regarding the simulator. It basically holds all of the functions for the simulator actors. There's a highlight function. There is a low light or deselect function. Basically, it turns off what the highlight for each of the actors. Delete, because you need to delete your simulator parts from the environment itself. Reference set, get charge, and reference grabbed are specific functions related to the circuits themselves, and also a part of the previous group's work that we had to rework in order to make for our goals, to meet our goals for the simulator. So let's take let's look at an example for one of these implementations of this interface. So here is a switch blueprint, and if you want to look at it, let's see. Here is the switch blueprint. It is basically the switch that toggles on and off to determine whether a specific charge goes through. As you probably have guessed or have seen, we use a Boolean to determine the 0 or 1 value of the charge of circuits. Let's see. So if we look closely here, here's a whole bunch of disposable interface events for this project. There's a highlight. This is covering it. Highlight, low light. These functions are attached to a highlighter. Now, highlighter is a material decal that we have attached to all of the actors. If you look at the viewport, you'll see that there is a hitbox for highlighter. This basically will highlight the actor green when the highlighter function is triggered. In this case, it's triggered by the player pointing their cursor at the actor. Where is the event graph? There it is. There's a delete function, very self-explanatory. You delete the actor. And then there is this reference grabbed and reference set related function. Reference grabbed was a interim function that we were using because previously what we had to do was that there was a button that we dedicated for the controller to grab a reference to one actor and then set it to another actor so that it would know that those two pieces were connected together. Reference grabbed is not really used anymore, but reference set is currently for our 3 actors. There's only 3 actors that we were able to rework for the simulator, and that's the switch, the wire, and the light. So, the switch turns on, a light goes through the wire, very simple circuit. Where is the reference set? Event, interact. Is that it? Oh, wait, no, sorry, my bad. There's no way that you could set a reference because generally switches are starting points, so there's no reason to set a reference. Starting points don't need to have to connect to something. We need to look at a different blueprint. Wire blueprint should work. Yeah. Okay, so here's a reference set function. These are just debug messages that I use to print during the testing to see whether they actually set or grab properly. And then we have a previous component variable here to set to know that this is what this component, this wire, is connecting to. So in this case, the wire is connecting to the probably the switch, and then we have it for the light actor as well. The light will set their reference to, in this case, a wire. Technically, if you have it set up properly, you could have wire overlapping wire, light overlapping light, unfortunately, and then you could make a really mismatched circuit. Here are the functions related to our simulator. We used a hitbox in order to detect whether we have a component that is also disposable. If it is, then we set that actor as our previous actor, and then we check a specific thing. A little bell and whistle that we were supposed to apply is the concept of circuit cycles. Now, if you have taken CS351, computer architecture, you should know about this, but generally circuits run on an electrical cycle. They don't automatically change instantly. So we have our circuits running on a basic timer. It just goes on a 2-second loop. It checks whether it is it just checks whether it has a previous component. It gets the charge or the boolean from the previous component, and then sets the charge for itself. In this case, has power, is powered. This is related to a different function. Is powered just checks whether the boolean is true, then it sets its own boolean value to whether it is true or false, and then since it's a wire, it will highlight blue if it has a charge, and it will highlight orange if it doesn't. Let's see. Yeah, I think that's about it. Thank you for watching the video. If you have any questions regarding anything, I'm sure you do, because some of the blueprints were not exactly very nice to look at. Feel free to contact me. If you ask Professor Gill, he should give you my Discord information or ways to contact me. And yeah, that's it. Good luck coding. It's as we have found out ourselves, it is actually kind of a nightmare to work off of someone else's code to try and build something for yourself. So good luck.